I have this friend of mine who always jumps to touch the top of a room doorway. He also always tells me about the games and the shots done by the players at the NBA. I also remember him telling me about Baron Davis's shot, which is the longest by far ever recorded by the NBA.
It's good! Baron Davis has just fought it in from 92 feet away.
So, as a physics lover student who is a friend who is a basketball enthusiast, we both have the same question in mind. How did Baron Davis do it?
You know what? That's the guy most people think.
Aside from perseverance, there is a much need for training in making a basketball shot. As we all know, one should put in time and effort to perfect something. Anyway, as a physics student, I have learned and seen that physics is involved in making Baron's shot. If you know this major physics concept and is able to apply it in real life, maybe you could beat Baron's record once you're in the NBA.
It's good! Baron Davis has just fought it in from 92 feet away.
Moving on, let's get the recipe. What is this concept? That's right, this is what we call projectile motion. Projectile motion is the motion of any object that is thrown, projected, or given an initial velocity and which follows a path entirely determined by gravitational acceleration and air resistance. The path traveled by the object is what we call trajectory. Now that we've got our concept, let's move on to the estimations.
He's got 50 points.
Given that the initial position of the ball and the ring is at the same height, the range of 27.1272 meters, which is equal to the 89 feet reported by the NBA, and an estimated angle of 60 degrees, as well as the gravitational acceleration, which is 9.81 meter per second squared. What would be its initial velocity? Well, here comes the fun part. With all of these equations of projectile motion, we are going to use the equation where all of the given values will be used. Given the range, angle, and acceleration of y-axis, which is the gravity, what equation are we going to use? Correct! The equation range is equal to the quantity of initial velocity squared sine 2 theta divided by gravity. Since we are looking for the initial velocity, we are going to derive the given formula to a formula where we find the initial velocity. This one's my favorite part. Using the given values, we will be substituting those on the derived formula. Now we have initial velocity is equals to the square root of the quantity of 27.1272 meters times 9.81 meter per second squared, divided by the quantity of sine quantity 2 times 60. After the computation, we will have the answer 17.5296 meter per second. Therefore, if you jump to as high as 3 meters and started throwing the ball with the velocity of 17.5296 meter per second, you'll be able to equalize Baron Davis's shot of 89 meters. But if you want to break his record, you might have to increase the velocity if the angle is at 60 degrees. Physics is everywhere. It is also the recipe to win the game. I hope you learned something new today from me, and I hope to see you again next time. Goodbye!